All right, welcome back everybody to the Python primer for student researchers. Today we're going to be talking about data visualization, which is a fancy way of saying graphing. In a lot of ways, we're going to be talking about graphing today, in particular using something called Matplotlib, which is a plotting library that's, if you've ever used MATLAB, it's very similar to that. If you haven't used MATLAB, it's very similar to Mathematica's plotting packages and all the things that you can do in either of those you can do in Matplotlib. So we're going to talk about that today because it's one of the most widely used plotting packages in Python, although there are quite a few others, but that's the one we're going to be talking about today. So the first thing we're going to do is import that library. And to do that, we're going to say import matplotlib, and we want a particular part of it called pylab. And I'm going to bring that in as plot, PLT. So this is something you'll see on a lot of other websites using Python. This is kind of a standard way of pulling in Python, matplotlib to Python. So hopefully this will be something that you can see in other tutorials if you go check those out. So that's just importing the library. And this PLT is going to preface everything that we do in our plotting packages. When we want to make a plot, we're going to say plt.plot. If we want to show the plot, we'll do plt.show. So that's, you'll see how that works in just a second. Okay, so I'm going to go ahead and execute that so that I have access to that. The second thing we need before we do any graphing is some data. So from our last video, we had a way of pulling in data from a website. So I'm going to go ahead and just copy that over from our last document. So if you go back to your last document, you'll see something that looks very similar to this. This is our pulling the sunspot data from a web URL and storing it in the dates, numbers, and standard deviations. And that's what is happening right here. So I'm just going to execute that so I have access to that. So now I have my plotting packages and I have access to data. If you don't have access to this data file for some reason, or if you just want to get started, you can do this by just creating a couple of lists. You know, if you just say x is equal to 1, 1, 2, 3, 4, and you say y is equal to 10, 12, 14, and 18, then you can plot those. Whoops. And you get a graph. Okay, so it's not a terribly interesting graph, but we're gonna use the data from the sunspots to make that a little bit more interesting. Okay, so let's go ahead and delete this real quick. Whoops. And we're going to execute our data file, and then we're going to start to make some graphs. Okay, so we've got in our data file, we have the dates, the fractions of years where these data were taken, and then we have our numbers. So let's go ahead and see what that looks like if I just plot that. So I'm going to say plt.plot, and the first list is going to go in the X column, and the second list is going to go in the Y column. So this is going to plot the dates on the X-axis and the numbers on the Y-axis. And then I'm going to say plot.show because that finalizes the plot and puts it on the screen. One of the things we'll find out as we go along that if we want to add things and show more than one thing on a given plot, we just need to execute multiple plot commands before doing the plot.show. So then I do a shift enter to see what that looks like. And there's our data plot, and it's showing the number of sunspots as a function of time from 1818 all the way up to 2020. And it's showing this periodic oscillation of sunspots that's known as a solar cycle. All right, well, a plot is only as good as how well it's annotated, so we need to add some things to this. So the first thing I'm going to do is I'm going to change this to data points. This is plotting a line by default, but if up here I say I want to plot blue circles, that's going to make dots instead, okay, which is something we're probably more used to when we're plotting data. And then I want to put a label on this so that I can have a legend. So I'm going to say the label is the number of sunspots. And then I'm going to put a legend on here. So I say plt.legend. And now that's going to put a little legend up there so that people who are reading my graph know what I'm talking about. I also need to put on some labels. So I can say the X label is equal to year of observation. And that's going to put a little label down there. I can do the same thing for the Y label. Oops. I can type. We're going to call this number of sunspots and hit return. And there we go. We've got our nice graph here that's showing number of sunspots, year of observation, and that's looking really, really good. Okay, so one of the things that this is fine for output right here on the screen, but if we want to do something where we want to maybe save this plot for publication, we want to make this a little bit more attractive and easier to read. So I'm going to use a couple of other designations which allow me to set things like the figure size and the font size. So I'm going to say plt.figure, and I'm going to say the fig size is equal to, say, 12 by 8. Okay, so it's a 12-inch by 8-inch plot. And then the dots per inch, let's make that 100. And the face color is white. Make that W. And the edge color is black. I'm going to use a K for black so we don't get confused with blue. And then I'm going to call on this thing called RC params to update my font dot size to 20. So it's just going to make my font a little bit bigger. And a lot of this looks like a bunch of jumbled code, and it kind of is because I've read the documentation for Matplotlib. But if you use this on your figures, you can make a nice publication quality diagram. So I'm going to go ahead and run that and see what we get. So when I do that, I get this much larger figure. Let me make that a little bit smaller so you can see it. So that's a nice, attractive figure for publication. The fonts are large. Everything's very readable. It has a legend. It has our designation for the axes, so we know what that looks like. The next thing we'd like to do, though, is we would like to plot some error bars on this figure because we have that information. We have error bars in terms of the number of the standard deviation for each one of these data sets. So let me make this a little bit bigger again so you can see it. And I'm going to reduce this in size just so you can see a little bit. Let's make this 6 and 4. So you can just see that right there. And I'm going to reduce the font back to about 12. So you can play around with that, make it as nice as you like. Okay, so now what we're going to do is I want to plot some error bars on this. And to see these error bars, we're plotting this full section of data. I just want to plot a small section of this. So I'm going to do that by setting the limits on my axis. So I can do that by saying plot dot xlim, and then put a list in there that has 2 elements. And let's go from, say, 1826.5 to 1827. So we're just going to look at 6 months worth of data. That's going to zoom in on that. And then let's change the y limit, plot.y limit, to, say, 0 to 300. And now we've got a nice zoomed up piece of the data here so we can see what the error bars look like. And now I want to put error bars on that. And to do that, all I need to do is add another line here. I'm going to call plot.errorbars. And we're going to set the dates, the numbers, so that's the X and Y axis. And then we're going to set what the error bars are, which is the standard deviations. And then we're going to make them circles. The data points themselves circles like that. If I do that, whoops, oh, error bar, not error bars. Okay, there we go. And what I should get when we do that is a graph once it's done running that shows my error bars. And you'll notice that it's kind of, I'm not seeing the dark blue here because of this. This is getting the label here. So what I'm going to do here is I'm going to take this label and I'm going to add it to here, and I'm just going to get rid of this line. It's kind of unnecessary because it'll plot the error bars just all by themselves. And there we go. And now you can see that it's replaced that with the proper symbol there. Okay, so once you've got a figure that you want to share with other people, you need to be able to save it. So instead of doing this plot.show, what we're going to do is we're going to save this figure to a file. Now, one thing you can do because you're in the notebook is if you right click on this, you can say save image as, or you can do plt.saveImage or save fig and put the figure name right there. And when you do that, it will save that figure into your working directory. All right, so that's how you do some basic plotting with Matplotlib. If you want access to the full range of these things, all you need to do is go to the Matplotlib Gallery. And the notebook that I'm providing here has the web link to that, or you can just Google Matplotlib Gallery, and you'll see a whole host of really cool examples. And we just go over there right now, you'll see the whole list of things that you can do in Matplotlib. These include things like, bar charts, you can do lines, you can do scatter plots like we've been doing. You can do all sorts of things, including up to manipulating images, doing contour plots, pretty much you name it, you can do it. So there's a place if you want to see what's possible. So if you're interested in one of these, you can come in here and they have the code right here. You can just copy the code into your notebook. And it will plot it right there. And you can play around with that and see how that all works. All right, so there's our little demo of Matplotlib for how to make graphs in Python. And next, we're going to be looking at some statistical tools, including interpolation, linear regression, and curve fitting. So we'll see you over there.